Hello everyone, welcome back to Linked Frequency. In this tutorial, we are going to learn about how to design a soil moisture sensor module using LM358 operational amplifier. This is the 9th tutorial of practice project for PCB designers, and I am Vaibhav Sugandhi, passionate PCB designer and technology startup founder. This tutorial is majorly focusing on the designing this kind of a soil moisture sensor, which can be directly inserted in the soil to measure the moisture content available in that soil. Again, we are using a operational amplifier, which is essentially required for deciding whether the soil moisture level is below the average or above the average. We will be setting that particular sensitivity level by using some setting resistor. So this is all about the tutorial. We'll get started with the block level analysis and then design a circuit in EasyEDA. Here we have our black box analysis. The first thing is we need to have a sensor electrode, which is made up of a steel or maybe a copper kind of a material. In our case, it is a PCB trace, which is again a copper on the substrate like ceramic material. And then that particular thing as an electrode will be connected to the operational amplifier so that we can decide whether the sensitivity or whether that particular moisture content inside a soil is below the average or above the average. The average is set by using the sensitivity resistor knob, which is like setting an offset value. If above the value, then it will be generating a high voltage at the digital side, and it is below the value or below the offset value, then it will be generating a low value on the output side. Altogether, this entire electronic to work, we need to have a DC power source. So we need to be giving a one connecting point where we will be connecting a DC power source, maybe a plus 5 volt at this point of time, but this particular sensor can work with a 3.3 as well. Most of the cases, we will be using a plus 5 volt DC here with a good amount of current rating, somewhere around 200 to 300 milliampere of minimum requirement. If you provide 1 ampere also, it doesn't damage. However, it works properly. And we will be having some indicator resistors where the one indication will be a power indication, which will indicate whether the power is given to this module or not. And one more indicator, whether the output is above the average or below the average, or above the set value or below the set value. Then we will be having a connectors, which will be helping us to connect the entire sensor with the microcontroller units or a development kit. So this is how the black box analysis looks like. And if I go for the white box analysis with a little bit of datasheet analysis and a morphological chart, which we discussed in our previous tutorials, this is how the white box analysis looks like. First thing is steel or copper plates are necessary to consider for the sensitivity detection or the insertion probes, we call them. Right now we are doing with the copper plate only. And then the LM358 or LM393 operational amplifier is being used as an op-amp or the signal conditioning unit for the soil moisture sensor. And 5 volt DC power supply has to be given, that is straightforward. And we will be having a 4-pin 2.54 mm pitch wala header just to connect the signal and the power source to the entire module. And we'll be using a 100K variable resistor to set the offset value or set the sensitivity value. And we'll be using a 2 red color LED, one for indicating the power, one for indicating the output signal. This is all about the very simple basic soil moisture sensor. If you go for a higher end soil moisture sensor, higher end design activity for the more accuracy and more sensitivity area, then obviously the sensor design has to be done in a more professional way. Since it's a beginner tutorial, I'm not more focusing on the more complex circuits, focusing on the PCB designing practice rather than the circuit complexity or accuracy. That's why we have done this particular circuit in a simple way. And this is how the circuit design looks like with a reference from the internet only. I have not taken anything from the datasheet and all. It's exactly from the internet, which is absolutely same to same soil moisture sensor available in the DIY segment of the industry. There we can see that this is where the moisture probe will be connected. A plus probe and a minus probe, it is indicated, but you can swap them also, it still works because it's ultimately a copper connecting electrodes. And then we will be having this, the knob here at 10K potentiometer is available, 10K or 100K based on which IC you are using. So if it is a 10K, then you have a sensitivity range very well, changing from first pointer to the third point. You can change the value and change the sensitivity. And this is operational amplifier. And we have one trigger LED which will be turned on when the output of this operational amplifier is high based on the soil moisture sensor level in the soil. And another LED is there which will indicate the power, whether this entire device is powered up or not. Again, you can see here in the VCC's level, we can provide a 3.3 volt, it still works. and if you provide a 5 volt, it still works. So you have a very good range of input voltage from 3.3 volt to 5 volt. So these are the 4-pin connector that we are providing to the user so that they can interface this entire module with the microcontroller development board, or maybe any kind of a device that wants to monitor the soil level. So this is all about the theory about this particular project. Now let's jump into the EasyEDA and start with designing our soil moisture sensor. First thing, I'll go to the EasyEDA and start with the file section, go to the new and start with the project. I'll keep it as a folder in my name only, and I'll name it as a soil moisture sensor module. Alright, so I'll not give a description at this point of time, so I'll just click on the save option and the new canvas arrives, and let's start as we do all the time. Alright, now you can see that this particular circuit is ready. The schematic for soil moisture sensor device or the module is ready now. You can see that I have used these VCC symbol and a ground symbol in a very proper way in this particular design. Why? Because we don't want to draw a wire from one point to another point and making it a very confusing which we can see in this particular diagram. Because this is a circuit diagram on the internet, so make it easy for the DIY project and breadboard people. So they have made this one. Those who are doing it on the breadboard and all, this kind of a circuit is essential. For those people who are into a PCB designing industry, using these symbols and these net label or a net port is very essential and very uniformed and a very professional one. That's why I have created this entire schematic by using these symbols in a professional way. I hope you understand it, and I hope you could make it by yourself by watching this particular video. Now let's jump into the PCB layout design activity, and we'll start on the PCB designing. Do remember, we have given the two connector for the soil moisture sensor connectivity, and we need to make a copper track for them. We should not be leaving them alone just to connect the external sensor. We want to make it a integrated sensor with the differential circuit. So now let's jump into the PCB designing. All right, now you can see that the PCB part is completed. Here we have a PCB with a very different dimension because it is a soil moisture sensor, as we discussed in our this PPT. Actually, you can see that in the first slide. You can see this is how our soil moisture sensor looks like. Because of this particular dimension, which is easy for, like a sharp needle kind of a thing, which is easy for inserting inside a soil, so that we can easily measure or insert it in a very different types of soils and measure the soil moisture level. We are designing a PCB with that kind of a dimension only. I have made it a little sharp. You can make it a little bit not so sharp. Try this yours. So right now, that is how we need to make this particular PCB. That's why we are going to use a board outline layer and use the wire tool to create the custom board outline. That is a new learning in this particular tutorial. That's why I purposefully chose the soil moisture sensor in this particular practice project for PCB designer. Why? Because we need to learn how to customize our board outline as per our requirement as well. Okay. So this is how our board outline can be drawn by using this wire tool, using a board outline. And then after that, when we connect our soil point or the layout point to the particular copper here, we need to expose that copper by clicking on the copper and expose it to the exposed copper option here. And one side is a ground, another side is the positive part of the sensor. And this particular sensor is connected to this particular electronic circuit, you can say. Because of the complexity, we are using a one jumper here, a small jumper, just to make it easy for our design activity. Of course, we can do it in a two-layer PCB designing and make a copper visible or available on the top side as well as on the bottom side. But right now, as it is a practice project and we need to learn how to design our system inside a limited constraints or limited offers, then we need to learn how to do it in a single layer copper. That's why I have used only a one jumper here using a 2 wires and finished the entire circuit. This is how it looks in 2D diagram, bottom side view, because on the top side there is nothing, because just a component on the top side. And in the bottom side you can see that these two coppers are exposed, or these two layers are exposed with a copper. And in 3D view, this is how it looks like. You can nicely see this particular copper exposure and all the sharp kind of a PCB design. And there is no PCB board in the middle, and there are two connectors here which you have to make it as a do not populate, which means you need not to solder these two things because they are already available with respect to this particular point. And this is how our electronics looks like. One LED is for indicating the power, one LED is indicating the output signal. This is LM358, the operational amplifier. So all about this entire soil moisture sensor design with an integrated circuit or a sensor circuit is completed. I hope you learned something new in this, very especially the way of drawing the copper board outline, and also the creating a copper pads like this using this solid region. These are the two new learnings as a fundamental for this entire tutorial. I hope you will learn it by doing it by yourself. If you have any doubts, do let me know in the comment section. I am more than happy to answer your question at any point of time. And most importantly, once you're done with this project, try to do it in a more optimized way by reducing the size, or reducing the complexity, or removing this jumper and all. That will give you a lot of knowledge while you're trying to solve that particular problem. As a PCB designer, you must have that kind of a creativity. So I believe that you learned something new in this particular tutorial, and I hope you enjoyed the entire tutorial. Now we are done with this particular project. We'll see you again in the next video. Until then, subscribe to our channel Linked Frequency for more such videos and for more such of educational content. Support us sharing this video with your friends and family members who are interested to learn PCB designing as a beginner. Thank you so much for watching. See you again in the next video. Until then, tune yourself to make a difference.